All right, this is Philip Kreisle. I have this is my second attempt at this. Talked way too long. I was like at 8 minutes and I got halfway through it, so I got to go quick. This is my model here. I know it's kind of just organized right now. It's because I just ripped it apart from halfway through it. This is an individual atom. It's oxygen. Here's also hydrogen. I made them with foam balls and wrote the letter on there for which atom it is. This is carbon. So these are my individual atoms. They come together to make molecules like H, not HOO. H2O, and also other molecules like CO2. This is a liquid. This can be a gas. Other molecules like NaCl, if you had Na and then Cl here, that can be a solid. Those are different substances that you can model. A model of a extended structure would be this here is H4, and that is methane. But if you take off an H, you add another C and two other hydrogens, you're building on to what you already have. Now you have two hydrogens. You have six hydrogens, two carbons, six hydrogens. Now you have ethane. Do it one more time. We'll do it real quick here. We'll throw another C on. Just want to model it for you because that's what the point of this is, to model it. Ooh. Get on there. All right. Now we have C3H8, and that is propane. Keeps going. 4 carbons, butane. 5 carbons, pentane. 6 hexane. 7 heptane. 8 octane. All the way, 10 decane. Anyway, so that is my model. All right, models are important. Models help describe the. That's the standard. What we're doing there. Using models can help students participate in the next generation science standards principles, such as communicating ideas, arguing based on evidence that they can actually see in front of them, and developing understanding of scientific and engineering practices and core ideas. Developing and using models is described as one of the 8 essential practices in a new framework for K through 12 science education. And models are explicitly referenced in the relationship to 3 other essential practices: designing and conducting investigations using mathematical and computational thinking, and constructing explanations. As a result, models are represented heavily in the final version of the next generation science standards. Models in science are selective representations of the natural world used to aid thinking and communication. Their designers select some aspects of the world, observable or inferable, to represent for particular purposes, to help themselves or others see patterns, to identify relationships or mechanisms, to construct or communicate explanations, or to make predictions. Very important to have models. Some strengths and weaknesses. Some questions to ask yourself when you're thinking about the strengths and weaknesses of your model is what learning goals will this achieve? depending on what you make it for, this obviously helps with the standard that we have, but it can help with a lot of other standards. Anything to do with atoms, anything to do with molecules, it can help with. So that makes it pretty strong. With the content, what are the content ideas that align with the model? It's kind of the same area. How does the model help students reach their learning goals? They visualize, they see what's going on there, they see how they're bonding together. We're not actually talking about valence electrons in this standard, but you could even help with that later on. Talking about you could have little electrons around it, talking about how they combine with it. And what is the role of the student and the teacher when you use this model? Obviously, the teacher will be walking around making sure they're getting them right, getting them in the right spots. It's simple, it's easy. Some weaknesses of this model is it's not very professional. It's thrown together pretty quickly. I did it pretty quickly. They will not last very long. You can't save this for next year or next semester. Hopefully they make it through the entire year. Or the entire lesson, because they break off, and you might have to redo the letters on there. Toothpicks break easy, so those are some strengths and weaknesses. I think that models, they explain phenomenons. They help you to share your understanding with other people. There's structural models. There's also behavior models. Behavior models show how things behave. You could use that for this if you bring in the valence electrons. Structural, obviously it's a structural model. Anyways, hope you enjoyed my video. I tried to rush through it. It's probably still really long because I talk a lot. Anyways, have a great night.